Okay, so to draw the Lewis structure for SO3, you have to start with how many valence electrons it has, and it has 24. So I'm going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So all of the valence electrons are used up, but S still doesn't have an octet. So I have to put a double bond from one of these O's. And this one actually has 3 different resonance structures because you can have a double bond on either of these. So the molecule would look like this. Because they're sharing these electrons in all 3 places. So to figure out the partial charges, O is the most electronegative, so it will have partial negative charges, and S will have a partial positive charge. And to draw the bond dipoles, you draw the arrow pointing to the most negative, so they're all pointing to O. And to figure out the net dipole, you have to draw out the molecular geometry, which looks like this. It has a trigonal planar molecular geometry. So here are the bond dipoles, and it has 3 domains, and since all 3 of the domains are the same, the net dipoles, the bond dipoles cancel, and there is no net dipole, so the molecule is nonpolar. So for OF2, I have the Lewis structure here. It has 20 valence electrons, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Every atom has an octet, so for the partial charges, F is the most electronegative, so the 2 F's will have partial negative charges, and the O has a partial positive charge. And the bond dipoles will point to F because it's the most electronegative. And to figure out the net dipole, I'm going to draw the molecular geometry again. There's 2 non-bonding pairs on O, so that's, and then the 2 F's. And here are the bond dipoles. And since there are 4 domains and they're not all the same, there is a net dipole going down, and that makes this molecule polar. For CCl4, it has 32 valence electrons. So for CCl4, it has 32 valence electrons. So I'm just going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So all the atoms have an octet. And for the partial charges, Cl is the most electronegative, so all of the Cl's will have a partial negative charge, and the C will have a partial positive. And for the bond dipoles, they're going to point to Cl because it is the most negative. And to figure out the net dipole, I'm going to draw the molecular geometry. and its molecular geometry is a tetrahedral. So I'm just gonna draw that. And here are what the dipoles look like. And since there are 4 domains that are all the same, the bond dipoles are gonna cancel. So there's no net dipole, so this molecule is nonpolar. All right. For BeCl2, there are 16 valence electrons. So I'm going to count 2, 4, 6, 8, 10, 12. So minus 12 is 4. So I have 4 left. And I need to make a double bond here and a double bond here so that Be will have an octet. Okay, so partial charges, Cl is the most electronegative, so it's going to have a partial negative charge, and Be will have partial positive charge. The bond dipoles will point to the Cl's because they're the most negative. And this molecule has a linear molecular geometry, so it will look just like this. And since there's only 2 domains and they're both the same, the bond dipoles are going to cancel, so there is no net dipole, so this molecule is nonpolar. Okay, and for O3, there are 18 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16. I need to add a double bond right here to give this center atom an octet. And this one also has another resonance structure because I could add a double bond here too. So I'm just going to draw what this molecule would look like. Here is the resonance because the electrons are sharing in both of these places. Okay. So these are all the same atom. They have the same electronegativity, so there isn't any partial charges and no bond dipoles. So to figure out if it is polar or nonpolar, I'm going to draw the molecular geometry. It has a non-bonding pair at the top, and then these 2 at the bottom. And since this is a bent molecular geometry, and since it has this non-bonding pair right here on the central atom, it makes it polar. Alright, so O3 and OF2 are polar, and SO3, CCl4, and BeCl2 are nonpolar. And some common mistakes: don't forget to think about the non-bonding electrons on the central atoms when determining if the bond dipoles cancel, because if there is a non-bonding pair, then they don't cancel and it'll be polar. So